Okay, last little bit of 2.2, the difference quotient. So this is a big mamma jamma for calculus. So since some of you are taking calculus, we all get calculus or, intro, very little bits of it because the university doesn't have two different college algebra tracks. It's just everyone takes the same. So you all get the same. So recall that the difference quotient from the first page is f of x plus h minus f of x all over h. This thing right here is the difference quotient. I want you to think of it as three separate parts. Part one, part two. So here's part one, here's part two, and then all of it is part three. Looks like a little monster. Rawr. Right, y'all see that? Like the eyeballs, there's crazy little mouth in the head. See? I know. All right, so I want you to break it down into three different pieces. But first, we're just going to baby step our way into it. So reminding ourselves what we did from 2.1, if I just want to evaluate f of x plus h, well, remember, it's the exact same process as if I was going to evaluate f of 2. If f of 2 says 2 times 2 quantity squared minus 2 plus 3, then we are doing the exact same thing, but instead of where we substituted in our 2's, we're now throwing in the entire expression of x plus h. So this is 2 times x plus h, quantity squared, minus x plus h, all plus 3. So remember, I harped on it before, I'll harp on it again. Do not drop your parentheses. Important, right? Seems like a tiny little, like, who cares detail. I get it, I'm with you. But actually, we all care. We all care very much so, okay? Because remember, it is part of your instructions. If you didn't have the parentheses, you may not recognize that you need to distribute or AKA FOIL out the x plus h squared. So we see that this is 2 times x squared plus 2xh plus h squared minus, notice that this negative has to get distributed to both the negative x and the h, right? Because notice if you don't have the parentheses, you may not recognize that, and then plus 3. Then we need to say, oh, okay, see, still with the parentheses, now we have to recognize that, oh, that 2 out front goes to all 3 of that trinomial term. So it's 2x squared plus 4xh plus 2h squared minus x minus h plus 3. And now we want to combine any like terms. So we have, oh, we don't have any like terms because here's an x squared, here's an xh term, here's an h squared term, an x term, an h term, and a 3 term. So no like terms here, so we are just done. But again, just practicing that crazy wonky x plus h or f of x plus h. Don't let it fool you. Okay, you can do it. You're so smart. Okay, so B. We're going to use the same thing. So A was already our step 1. Remember, step 1 is f of x plus h, but we already did that in step A. So go us. Okay, so that's your step 1. Step 2 seems very, very weird, but I want you to do it because over and over again, if a student is going to miss a step, it is distributing this negative to the entirety of f of x. So I want you to have negative f of x as your step 2, however silly and I don't know, just extra it may seem. Remember, mathematicians are inherently lazy. I will not make you do any extra work that may not necessarily be lazy, may not necessarily be needed because we are lazy, right? Work smarter, not harder. That's why we do a lot of 2 birds, 1 stone type of stuff. All right, so now this negative 2x squared plus x minus 3. So notice every sign flipped. Again, that's why I have this as separate step 2, because I see it all the time. The first sign will flip, but like not anything afterwards. So it just kind of like helps cover your butt. Then step 3 is, I'll even do it in a different color. It's what we have from step 1 plus what we have from step 2 all over h. And again, looks like a crazy monster. Rawr! Oh, it just gets me every time. So from here, and this is what's really cool, actually. I'll save the cool. Oh my gosh, it's just so, y'all, it's just so flipping exciting. Let's see. Okay, I'll set it up and then I'll tell you the excitement. So I'm just autopilot writing down what I got from step 1, or part A in this case. And then just right behind it, just writing down what I got from the second step, right behind that, except 3. Okay. And then all over H. All right. I'm so sad we're not a person for this, because this is thrilling. Thrilling. Get this. Step 3 not only has 1 internal self-check, that's right, not 1, but 2. 2 self-checks that tell you, like, yay, you're on the right path. Because get this, every single thing from step 1 will cancel out with something from step 2. Oh yeah, that's right. So you know you're on the right path if everything from your step 2 zeroes out with something from step 1. Should just give you those nice warm and fuzzies inside, right? So 2x squared minus 2x squared minus 8x plus x plus 3 minus 3. So that's the first one, because remember, not 1, but 2. The second one, notice as I'm just writing this cleanly, what does every term now have in common? That's right, an H. Do you think that's an accident? It is not. This is on purpose. That's right. So this is your second self-check that should give you the nice warm fuzzies. That, yeah, you're on the right track, because everything will have an H, and then you'll take an H out of every position. So you're left with 4x plus 2h minus 1, because remember, you need a placeholder for that H right here. And that is, ta-da, your difference quotient. So break it down into 3 steps, right? You're doing f of x plus h minus f of x, and then 1 and 2 all over h for your step 3 entirely, right? So this whole thing is your step 3, if you would. Yeah, the difference quotient, y'all, it's so cool. I'm so excited for you that you just learned this. How fun. And that's 2.2.